All right, strap yourselves in because today we are going galactic.
Sounds exciting.
It is. We're doing a deep dive on galaxies.
Oh, nice.
Those incredible, islands of stars, gas, and dust all across the universe. We've got a ton of research, articles, even some of my own notes, and
Oh, wow.
let me tell you, it's wild out there.
I bet. I think what's so fascinating about galaxies is how much we sort of oversimplify them in our minds.
Yeah.
We see these beautiful images of spiral galaxies, and we
Mm.
just kind of think of them as these like serene, almost static structures.
Right, like those classic planetarium posters.
Exactly.
Just these perfectly symmetrical spirals. But something tells me these galaxies are anything but peaceful and static.
Oh, you're absolutely right. Galaxies are incredibly dynamic.
Okay.
They're constantly evolving, systems in motion, interacting with each other,
Oh, wow.
and sometimes even colliding in these spectacular events that totally reshape them.
Wow.
Yeah, think of them like giant cosmic construction sites where stars are being born, living out their lives, and ultimately dying,
Hmm.
and then contributing to this whole cycle of creation for new stars and planets.
So I love that analogy. Cosmic construction sites.
Yeah.
So if galaxies are the construction sites, what are they building?
Well, they're building the very fabric of the universe.
Okay.
I mean, everything we see around us, including us, can be traced back to the processes that happen inside galaxies. Think about it.
Yeah.
The atoms that make up our bodies,
Right.
the carbon in our DNA, the iron in our blood, all these elements were forged in the hearts of stars that lived and died within galaxies.
Hmm.
We are literally made of star stuff. Wow. And that star stuff was made in these massive cosmic furnaces.
That is pretty mind-blowing. So we're not just observing galaxies from afar, we're actually a product of them.
Exactly. We're part of this grand cosmic story that's been going on for billions of years.
Wow. Okay. And that story, is it filled with just incredible events?
Oh, absolutely.
Right.
Some of them are so powerful and energetic, they can completely reshape galaxies.
Hmm.
Like, for example, have you ever heard of galactic mergers?
I have, yeah. Isn't that when two galaxies collide?
Yeah.
I imagine it's pretty chaotic.
Oh, it's like a cosmic demolition derby.
Oh, wow.
You've got stars getting flung around, gas clouds colliding, shock waves rippling through the interstellar medium.
Oh,
But amidst all that chaos,
yeah.
something incredible happens. These collisions can actually trigger bursts of star formation.
Really?
When the galaxies collide, their gas clouds get compressed, and that can jumpstart the birth of a whole new generation of stars.
So it's kind of like a cosmic phoenix rising from the ashes of these galactic collisions. Destruction leads to creation.
It is. And that's just one example of the dynamic processes shaping galaxies.
Yeah.
Another one is something called galactic cannibalism,
Galactic cannibalism. Okay.
where larger galaxies basically eat smaller galaxies.
They eat them.
Yeah, they absorb their stars and gas. Our own Milky Way galaxy has done this several times in its history,
Oh, wow.
and it's still happening today.
Wait, so the Milky Way is a galactic cannibal.
It is.
That's kind of terrifying, but also really intriguing.
Yeah.
Does that mean we're on a collision course with another galaxy right now?
Well, not exactly right now, but yeah,
Oh, okay.
we are on a collision course with our nearest galactic neighbor, the Andromeda Galaxy.
Andromeda, okay.
But don't worry,
All right.
this cosmic rendezvous isn't happening for another 4.5 billion years or so.
4.5 billion years. Okay, well, that gives us some time to prepare.
Yeah.
But seriously, what happens when galaxies collide like that? I mean, is it like a catastrophic event?
Not necessarily. It's more like a slow dance, a gravitational tango that goes on for millions of years.
Okay.
The stars and the galaxies are so far apart that they rarely actually collide directly, but their paths get altered by the shifting gravitational forces as the two galaxies merge. And sometimes stars can even get flung out of the galaxy entirely. They become what we call hypervelocity stars.
Hypervelocity stars. So they're like cosmic runaways ejected from their galactic homes.
Yeah, exactly.
Wow, that's amazing. Where do they end up? Do they just drift through the vast emptiness of space?
That's a great question, and one that scientists are still trying to answer. Some of them might eventually find new galactic homes, while others could wander the universe forever,
Oh, wow.
becoming these solitary travelers in the cosmic void. What's fascinating about hypervelocity stars is that they give us clues about the immense power of black holes.
Okay, so black holes are somehow involved in launching these stars across the universe.
Yeah, imagine a star getting a little too close to a supermassive black hole at the center of a galaxy.
Okay, yeah.
The black hole's intense gravity acts like a cosmic slingshot, flinging the star out at unimaginable speeds.
It's like a cosmic game of billiards.
Yeah.
With black holes as these ultimate trick shot artists. Wow. So galaxies aren't only the birthplaces of stars, but also these launch pads for these super fast travelers.
They are.
It seems like there's a lot more going on in these galactic construction sites than we first thought.
Oh, absolutely. And we haven't even touched upon one of the most intriguing aspects of galaxies. Dark matter.
Dark matter.
It's this mysterious substance that makes up about 85% of the matter in the universe. And it plays a crucial role in shaping the structure and evolution of galaxies.
Dark matter. I've heard of it. To be honest, it's always kind of seemed like one of those esoteric concepts that only astrophysicists really understand. Can you break it down? What is dark matter and why is it so important?
It's kind of like trying to describe the wind.
Okay.
You can't see it directly, but you can see its effects. We can't see dark matter directly, but we know it's there because of its gravitational influence on galaxies.
So it's like an invisible scaffolding that holds galaxies together?
Exactly. Without dark matter, galaxies would fly apart because the gravity from the visible matter alone isn't strong enough to keep them bound. It's a mind-blowing concept. Everything we can see, all the stars, planets, gas clouds, that's only about 5% of the universe. The rest is this invisible stuff that we're still trying to understand.
That's incredible. It's really humbling to think that we've only just scratched the surface of understanding the universe and all the forces that shape it.
Yeah, and it makes you wonder what other mysteries are out there waiting to be discovered. But even with all that we don't know, one thing is clear. Galaxies are far more dynamic, complex, and interconnected than we ever imagined.
I'm already hooked.
Good.
But before we dive deeper into the mysteries of dark matter and the evolution of galaxies, I think we need a little break to process all of this. We've covered a lot of ground.
We have.
Galactic mergers, cannibalism, hypervelocity stars, and now this mysterious dark matter. It's like a whole new universe has opened up.
It has. And that's just the beginning. When we come back, we'll rewind the cosmic clock and explore the epic story of how galaxies themselves came to be. Welcome back to our deep dive on galaxies. Before the break, we were talking about dark matter and how it's this invisible scaffolding holding galaxies together.
Right, it's mind-boggling to think that everything we can see only makes up a tiny fraction of the universe.
It really is.
But before we get, too deep into those mysteries, I'm curious about how galaxies themselves came to be. We've talked about their evolution and the events that shaped them, but where did it all begin?
Right.
How did these islands of stars and gas first form in the vastness of space?
That's a question that takes us all the way back to the Big Bang.
Oh, wow.
To the very beginning of the universe.
Okay.
So picture this. The universe was just this hot, dense soup of energy and particles.
Okay.
A chaotic sea of potential.
Yeah.
But even within that chaos, there were these tiny fluctuations in the density of matter and energy, almost like ripples on a cosmic pond.
So these tiny fluctuations, those are like the seeds of galaxies.
Exactly.
The starting point for all the structure and complexity we see in the universe today.
Exactly. And gravity played a key role in nurturing those seeds.
Okay.
Over billions of years, gravity amplified those tiny density fluctuations, pulling matter together and forming the first clumps and clusters.
So gravity was like the cosmic sculptor slowly shaping the universe out of this primordial clay.
Exactly.
Can you give us a picture of what those early structures looked like?
Imagine these massive clouds of hydrogen and helium gas,
Okay.
swirling and collapsing under their own weight.
Okay.
As they collapsed, they spun faster and faster, eventually forming these rotating disks of gas and dust. And those spinning disks were the precursors to galaxies,
Okay.
the foundation upon which stars would eventually ignite.
So these swirling disks, they were like giant cosmic potter's wheels shaping the raw materials of the universe into the galaxies we see today.
Like that.
But how did those swirling clouds of gas and dust actually give birth to stars?
Within those spinning disks, gravity continued to do its thing. Denser regions within the disks began to collapse further, forming these even smaller, denser clumps of matter.
Okay.
And as those clumps contracted, they heated up, their cores reaching millions of degrees.
Wow.
Eventually, the pressure and temperature at the cores of these clumps became so intense that nuclear fusion ignited and stars were born.
Wow. So galaxies were essentially giant stellar nurseries.
Yes.
Churning out stars like like cosmic assembly lines.
Exactly.
It's amazing to think that the very first stars in the universe ignited within these primordial galaxies.
Yeah.
What were those early stars like? Were they similar to the stars we see today?
The first stars were very different from the stars we see today. They were massive, hot, and incredibly short-lived.
Really?
Burning through their nuclear fuel in just a few million years.
A few million years, that's a blink of an eye in cosmic terms. What happened to them when they died?
They ended their lives in spectacular supernova explosions, scattering the elements they had forged in their cores throughout the surrounding space.
So like giant cosmic recycling plants spreading the ingredients for new stars and planets.
Exactly. Those stellar explosions enriched the interstellar medium, the gas and dust that fills the space between stars, with heavier elements like carbon, oxygen, and iron.
Okay.
And those elements, in turn, became the building blocks for new generations of stars and planets.
So it's like a beautiful cosmic circle of life.
It is.
Stars are born, they live, they die, and in their death, they create the conditions for new stars and planets to form. But those early galaxies, I'm guessing they weren't quite the majestic spirals and ellipticals we see today.
You're right. Those early galaxies were smaller, less organized, and much more chaotic than their modern counterparts. They were constantly colliding and merging, their shapes and structures evolving as they interacted with each other. Imagine a cosmic dance floor filled with swirling galaxies, bumping and grinding, exchanging partners, and sometimes even merging into new, larger galaxies.
It sounds like a wild party.
It was.
So it was through this chaotic dance of mergers and interactions that galaxies grew larger, more complex, and eventually evolved into the magnificent spirals, ellipticals, and irregulars we see today.
Precisely. It's a process that's still ongoing, with galaxies constantly evolving and interacting with each other. And as galaxies evolved, so too did the stars within them.
You mean the later generations of stars? The ones formed from the remnants of those early supernova explosions?
Exactly. Those later generations of stars, enriched with heavier elements, were able to form planets and solar systems like our own. And it's within those solar systems that the conditions for life as we know it emerged. So you see, we owe our very existence to the processes that shaped galaxies billions of years ago.
It's amazing to think that we can trace our lineage all the way back to those early galaxies.
It is.
To those first stars that ignited in the darkness. It really makes you realize how interconnected everything is. How our story is woven into the very fabric of the universe.
It's a story of creation, evolution, and interconnection. A story that spans billions of years and stretches across the vast expanse of the cosmos. And it's a story that's still being written, with new chapters unfolding all the time.
That's what makes studying galaxies so fascinating.
It is.
It's like reading a cosmic history book.
Yeah.
But it's a book that's still being written, with new discoveries and insights constantly changing our understanding of the universe.
And speaking of discoveries and insights, we've only just begun to explore what makes galaxies so captivating. Did you know that galaxies have magnetic fields?
Magnetic fields? I hadn't considered that.
These invisible forces play a crucial role in their structure and evolution.
Wow, it's amazing to think that there are these unseen forces shaping galaxies, guiding the flow of gas, and even influencing the formation of stars.
Exactly. It's like there's this hidden symphony of forces at play within galaxies, shaping their destinies and orchestrating their evolution over billions of years.
So these magnetic fields, they're like these invisible conductors shaping the cosmic orchestra.
That's a great way to put it. And just like the Earth's magnetic field protects us from harmful solar radiation, galactic magnetic fields can shield stars and planets from the harsh radiation of interstellar space. They can also influence the flow of cosmic rays, those high-energy particles that zip through the universe at incredible speeds.
It's incredible to think that these invisible forces are playing such a crucial role in the grand scheme of things. It makes you wonder what other unseen forces might be at work in the universe, shaping the cosmos in ways we haven't even begun to imagine.
Yeah. It's a tantalizing thought, and it really highlights the fact that we're constantly learning new things about galaxies, constantly revising our understanding of these vast and complex systems.
It feels like we've just scratched the surface of this galactic journey.
We have.
We've gone from the Big Bang to the formation of galaxies, explored the life cycles of stars, and delved into the mysteries of dark matter and magnetic fields.
It's a lot to take in.
It is. I think it's time for another pause.
Yeah.
Let all this new information sink in.
Definitely. When we come back, we'll delve into the amazing diversity of galaxies, their shapes, sizes, and even their colors. It's a visual feast that showcases the creativity of the cosmos.
Welcome back to our galactic expedition. We've journeyed through the birth and evolution of galaxies, uncovered the mysteries of dark matter and magnetic fields, and now get ready to be wowed by the sheer diversity of these cosmic wonders.
It's true. When we picture galaxies, we often default to that classic image of a spiral galaxy.
Right.
That flat disk with majestic arms spiraling outwards.
Yeah, like our own Milky Way.
Exactly.
Yeah, that's what I always picture when someone says galaxy.
It's an iconic image, but the reality is galaxies come in a stunning array of shapes and sizes. It's like a cosmic fashion show out there.
Okay, so beyond spirals, what other galactic designs are strutting down the cosmic runway?
Well, we have elliptical galaxies.
Okay.
Which are more like giant cosmic footballs,
Right.
smooth and rounded, with stars distributed more evenly throughout. Unlike the bustling, star-forming regions of spiral galaxies, ellipticals are more like the serene retirement communities of the cosmos.
So in elliptical galaxies, things have settled down a bit, less new construction, more relaxation.
Exactly. They tend to have older stars and less gas and dust, which means they're not as actively forming new stars. But they're still incredibly massive and can contain trillions of stars.
Wow. So from swirling spirals to giant cosmic footballs,
Yeah.
the universe certainly has a flair for design.
It does.
You mentioned irregular galaxies earlier.
Yeah.
What makes them stand out from the crowd?
Irregular galaxies are the rebels of the galactic fashion scene.
Okay.
They don't conform to any particular shape or structure.
Yeah.
They're often the result of galactic mergers or gravitational interactions that have kind of, distorted their forms, giving them a unique, almost chaotic appearance.
So irregular galaxies, like the abstract art of the cosmos, each one shaped by its own wild history.
Exactly. And just as every galaxy has a unique shape, they also have this vast range in size.
Okay.
We have dwarf galaxies, the tiny villages of the universe, containing just a few million stars.
I can't even imagine how small that is compared to our Milky Way.
Oh, it's a huge difference. And then on the other end of the spectrum, we have the absolute behemoths, the giant elliptical galaxies like, IC 1101.
Right, IC 1101, the sprawling metropolis of the universe.
Yeah.
I'm still trying to wrap my head around the fact that it's, 60 times the size of the Milky Way?
Yeah.
And contains trillions of stars.
Trillions.
It really puts things into perspective.
It does.
So, from dwarf galaxies to supergiants, the range in size is truly mind-boggling.
It is.
Does this cosmic fashion show also have a color palette?
It does.
I mean, are all galaxies just, a bland, starry white?
Not at all. Galaxies come in a stunning array of colors, and those colors reveal a lot about their stellar populations and the processes happening within them.
Okay, I'm picturing a cosmic galactic color palette.
Well, younger stars tend to burn hotter and emit bluer light, while older stars are cooler and emit redder light. So galaxies that are actively forming new stars like our Milky Way often have a bluish tint overall.
So blue for young and energetic makes sense. What about those elliptical galaxies, the ones with the older star populations?
Well, as you might guess, they tend to have a more reddish hue, a sign of their mature stellar populations. It's a beautiful contrast.
It is. It's like looking at a family portrait of the universe with, young, energetic blue galaxies alongside their wise, older red counterparts. But what else makes each galaxy unique?
Each galaxy carries this unique history, this cosmic fingerprint, shaped by the events it has experienced over billions of years. Collisions, mergers, gravitational interactions with other galaxies, and even, the influence of dark matter have all played a role in sculpting the galaxies we see today. No two galaxies are exactly alike.
So each galaxy is like a cosmic snowflake, a testament to its own unique journey through time and space.
Beautifully put. And just like snowflakes, galaxies are constantly evolving and changing. They're dynamic systems, shaped by this complex interplay of forces, and their story is far from over.
I think that's what makes studying galaxies so captivating. It's not just about understanding these distant objects. It's about understanding our place in this grand scheme of things, unraveling the mysteries of the universe, our own existence.
Absolutely. And as we continue to explore the vastness of space, with each new discovery, we gain this deeper appreciation for the beauty, complexity, and interconnectedness of the cosmos.
This has been an incredible journey. We've gone from the Big Bang to the formation of galaxies, explored their diverse shapes, sizes, and colors, and delved into the mysteries of dark matter, magnetic fields, and the powerful forces that shape these cosmic wonders.
Yeah, and through it all, we've gained a deeper understanding of our own place in the universe.
Yeah.
We are, after all, children of the stars, products of the very processes that shaped these galaxies billions of years ago.
What a beautiful thought to leave our listeners with. As you gaze up at the night sky, remember that those twinkling points of light aren't just stars, they're entire galaxies. Each one, a vast island of stars, gas, and dust. Each one a testament to the incredible power and creativity of the universe. Keep exploring, keep questioning, and never stop marveling at the wonders of the cosmos.
And until next time, keep looking up and keep asking those big questions.
Thanks for joining us on this deep dive into galaxies. We'll see you next time for another adventure into the mysteries and wonders of the universe.